Brecht is an amazing trainer. So if you've never followed his workshop, I said you should. And he's also a speaker. And let's welcome him on stage here.
Thank you. Thank you. Thank you for having me. Today I will talk about reactive patterns in Angular Enterprise Solutions. I know it's a super fancy name. One slide about me. I'm Brecht. I'm founder of Simplified Courses. I'm a freelance architect. I'm a trainer, a coach, an author, and I've been doing Angular training since it was still in beta phase. So I've traveled the world. I did a lot of workshops, a lot of coaching. Yeah, that's me. So, who likes RxJS? Can I see a show of hands? Who loves RxJS? Who loves RxJS code written by someone else? Or 6 months ago, you? It's hard, right? Because you have all these different map operators. We have concat map, switch map, exhaust map. We have different combination operators. We have scan, reduce. We have different subjects. We have a replay subject. We have a behavior subject. We have schedulers. We have multicasting. We have memory leaks if we forget to unsubscribe. And we have error handling. So learning RxJS is one thing, but understanding code written with RxJS, that can be kind of hard. So the schedule of today. We will face some template logic struggles. Later on, we will introduce the first reactive pattern called ViewModels. Then we're going to move on to local component state management. And later on, we're going to tackle smart component state management. After that, there is a small part about global state management. And yeah, I'm not going to tell you the other part. It's a surprise. So we're going to start with creating this beautiful pager component. And as we can see, this pager component has 3 inputs: the items per page, the total, and the page index. So calculating all these different pieces of state, where do we do that, right? We could do it in a template. And that's not really code I'm in love with, because there's a lot of complex template logic. And you can even see that I'm using math.ceil, and I have to actually expose the math class from my component instance to my template. We also have redundant logic and even redundant complex logic. All right. So how could we fix this? We could use getters, template functions, we could use pipes, but that's not really reactive. And the name of this talk is Reactive Patterns. We can calculate on the onChanges lifecycle hook, but that's kind of brittle. We don't have any nice type safety there, and we would have to write lots of conditional logic. So let's create behavior subjects. Behavior subjects are reactive. They're observables, and they always have an initial value and the latest value. In combination with input setters, we could actually create reactive properties. As we can see here, we have a few properties that are calculated. We have observables calculated based on other observables. And the total, we don't want to expose the subject to our template, because we don't want to expose the next method there. So we use the asObservable. The previous disabled is an easy one because we just have to map it. But if you look at the next disabled, so the observable that we will use when one of the next buttons gets disabled, it's based on 3 different source observables. We have the page index, the total, and the items per page. And as we can see here, this is reactive logic. This is where RxJS was built for. We have the same thing for item from and the same thing from item to. We can see that these observables are based by other observables. They're recalculated whenever one or multiple input sources change. So if we look at our template now, we have no more template logic, but we have 7 async pipes, which means we have 7 subscriptions. And that does not make me happy. So entering the reactive pattern number 1, ViewModels. A ViewModel is a reactive object specifically for our template. We have an observable for our template, only 1 async pipe, meaning only 1 subscription, and all our properties have initial values. Calculating this ViewModel can be done by using the combine latest operator in combination with distinct until changed. The combine latest operator would have to have source observable that always have an initial value, but we're using behavior subject, so that's fine. And the distinct until changed will optimize it for performance so that the observable only emits when one of the source observable actually has a new value. If you look at our template now, we can see that we have cleaned it up quite nicely. There is no more async pipes, there's only 1 async pipe, only 1 subscription, and we have a clean template. All right, there is one issue with this though, and it is called boilerplate. Why do we have to have behavior subjects just to create reactive inputs? It doesn't really make sense. There is a lot of code there. We have to use the setters, and we have to use the next method. And if we use a setter, it becomes impossible to retrieve the value, unless we're actually using the value property of our behavior subject. In our calculation of the view model, we also have boilerplate because we have 1 combined latest and 1 distinct until changed for every source observable. But what if I told you that I've created a convenient decorator for this that will actually listen to the ng on changes lifecycle hook, and only 1 time per change detection will update this reactive object with all the different input properties? Here we can see that it becomes quite easy to just consume our local input state and create a view model based on that. There is no more combine latest, and there is no more distinct until changed. So we have cleaned up the code quite nicely. We have 1 place where everything is calculated, only 1 async pipe, no more boilerplate code. So you can find it in this repository. People asked me to open source what I'm about to show today, and frankly, I'm too lazy for that. I don't have time for that, I have children, but you can just use it and own it yourself because it's not that much code. And it's actually something that I would advise people to do in general, not always go for something that already exists, but sometimes it's fine to own it yourself. You can add features, things that you are not agreeing with, you can change them. And to be honest, it's not rocket science. So what does this input state do? It creates an observable of inputs. It will only emit once in the ng on changes lifecycle hook, and it will clean up automatically. Also, it will distinct all the properties until they change automatically for us. And when I say cleaning up automatically, I actually mean that we would never have to do take until destroy again, because when the component gets destroyed, this little observable would also get destroyed, and it will automatically clean up our subscriptions. I have created a blog article about that, and since we're limited in time, I would just advise you to read it if you're interested. This shows how I created this decorator. Reactive pattern number 2, local component state. In our beautiful pager, we see that we have added 2 DOM elements, a show button and a drop-down that shows the items per page. In our pager UI component, we see that we have added 2 properties, but these are not reactive, and we cannot subscribe to the state. And we have 2 different types of state now. We have observable state, and we have regular properties. The combine latest also won't work, because they expect source observable rather than just plain properties. So to fix this, again, we have behavior subjects, and again, we have a combine latest and distinct until changed. And that's beautiful, but that's also not very beautiful because we introduced boilerplate again. The thing with behavior subjects is also that sometimes we're nexting multiple behavior subjects at the same time, causing the combine latest to cause two emissions there, having two calculations, which is also not what we want. This also feels kind of dirty to use the behavior subject API directly. We use the next and the dot value directly, and it feels a little bit dirty, but that might be a personal opinion. But in this specific scenario, if we use this in a combine latest, this will cause multiple emissions in the combine latest, and you could use a debounce time for that, but I'm pretty sure this will trigger a new cycle of change detection. I should actually know because I've written a book about change detection, but I'm pretty sure, and I'm going to double check. So the current issues that we have is we have only ng on changes that updates the input state. So that means that if we update the input state ourselves, our component won't react to that. It only listens to ng on changes. This is a very handy table that I can put my bottle of water on. So we also have to use the behavior subject directly. We have multiple emissions in the combine latest, and we have a lot of boilerplate. Entering the next reactive pattern, which is observable local component state. So observable state is also a custom implementation. And it's only 100 lines of code. It's very small, it's very simple, and it's just a behavior subject on steroids. So we always have a snapshot available if we want to, but we can also create an observable from it. I definitely would like you to check this source code because it's super simple. So the initial API of our observable state, we will start with 3 methods. The first one is initialize, and we always want to pass initial state. It forces us to reason about the state and to always have an initial state. It makes sense if you're doing loading and stuff like that. As a second argument, we can pass it the input state. It's an optional argument, so you don't always have to pass it, but if you do, this input state would also feed our observable state with changes. And then we have a patch function. In a patch function, we can pass a partial of our state. So we don't have to next multiple times. We can patch once. We can pass multiple properties there. And this will give us a snapshot and also an observable of the state. Let me show you how we can implement our PagerUI component. First, we just extend from observable state. You could also use dependency injection and provide it. But we chose this approach because it's easier if you want to write logging for it, and it's less dangerous if you have a child component where you forget to provide observable state. So we like to do it this way. We still have our input state, and we have our initialize function. And in the initialize function, we have a very clear overview of our initial state. As a second argument, we could pass our input state, and it will connect it to the reactive store. If we look at our view model now, again, we don't have any combine latest. We don't have distinct until changed. We can just take our state property and map it to our view model. Our toggle show items per page method also improved quite a lot because we have access to the snapshot, and we have our patch function where we can pass one or multiple properties. So what did we fix now? We have no direct usage of behavior subjects. We can patch partial pieces of state. We have a snapshot, but also an observable state. And if you think about reactivity, then the reactivity always comes from the top and goes to the bottom. That makes sense. But if you're clicking on a button, you just want to have the snapshot there. You don't want to do this.state, pipe, take one, subscribe, for instance. You just want to have a snapshot. It also works with input state. And here we come to the next reactive pattern, which is observable state for smart components. in general, I think it's a very good idea to treat our components as tiny little state machines. Here we can see that we have a beautiful web shop with some products, with some categories. It has a client-side filter, and it has a client-side pager. So if you would want to write this the old way, we again would have async pipe hell, and the async pipe emits NULL initially. So that means if you bind it to an input, then that input that is of type string, for instance, should be of type string or NULL, and that's kind of annoying. Again, we also have a lot of behavior subjects that we want to expose as observable, which is not code we generally want to write. And this is even a more important one. We're doing some multicasting here because we don't want to fire the getProducts call twice. But what if we forget to put the ref count to true? If there would be a source observable, this would introduce a memory leak. And you should know that as RxJS developers, but nobody really knows it, right? It's some of the things that makes it hard for juniors to dive into Angular because you need to know all these RxJS internals. If you look at the filtered products and the products, we see that we have a little bit more complexity. It's still fine. I mean, we have 2 combined latest, but who's been in code where we have more than 2 combined latests? That's not as much I was expecting. Anyone else? Yes, thank you for waking up. It can become hard, right? You have combined latest and with latest from, and you switch map it, and you do all that multicasting logic. It's hard. It's hard. What we also have as an issue here is that when we set the query, then it makes sense to reset the page index back to 0 because your paging wouldn't make sense anymore, causing, again, multiple emissions in our combined latest. So we're going to introduce a few new methods in our observable state. The first one is only select when. And only select when would return an observable. And that observable only emits if one of the keys that we select actually change. So this is a very convenient function that we can use to create state based on other pieces of state. We will see that the state of our component will always impact other states, so it makes sense to recalculate state based on other state. We have a connect method, and in the connect method we just pass an object where every property in that object is an observable, and it will subscribe only once initially, so we never have to worry about multicasting. It will take until destroy behind the scenes, so we don't have to worry about that either. It will just clean up our subscriptions. And then we have a pick function, and in that pick function we can just pick pieces of state from other global states, and so on. Looking back at our product overview smart component again, we just extend from observable state. We pass it some initial state, which is very clean and also opinionated. And now we can see that when the product or the query change, then the filter products should change. So if you're a junior developer and you're seeing this code, it should make sense that filter products is being recalculated every time products or query gets a new value. Let's take it a step further. And here we can see that we calculate the paged products on the filter products that we have just calculated, but also on page index and items per page. This will not work now, but it will work if we just connect it. So in the connect method, we will just connect our AJAX calls. As I said before, only one subscription, so no multicasting needed. We don't have to worry about handling subscriptions, and we can just connect the 2 pieces of state that we have just calculated. The connect function is something that is very pragmatic to use. let's say that you want to trigger change detection every second. You can just add a time property with an interval, which creates an observable with a new date timestamp every second, and you can just connect it. If you want to connect the X and Y coordinates from the user, you could just use from event and put it in the course as well. You still have access to all the different RxJS property operators that you're used to using, but we're just handling our state in an opinionated way. Calculating the view model again becomes easy because we just have to map the state. Again, if the items per page change, we want to update multiple properties, so we just use our simple batch function. Did I already mention that this entire thing is below 100 lines of code and is just a behavior subject behind the scenes? This gives you the chance to own it yourself. I'm not going to open source it. I have written articles about it. You can just grab the code from the repository and make it better for yourself in your own company. Then we have reactive pattern number 5, which is global observable state. And in the global observable state, we don't have to create state services anymore with behavior subjects. We just create reactive state services. The fact that we can pass a custom name here means that we can provide it in the app component. And for route, we can provide it on a route, we can provide it on a smart component, on a DOM component, which means it will automatically get cleaned up for us when that component or route gets destroyed. We can initialize it with an initial value, and now we have also created a specific API for this component, which makes it easier to use. We could also inject a product service, for instance, in here, and we could create that reactive logic in this component as well. So this is very nice that you can just use Angular dependency injection to have control over the lifecycle of your state objects. So wrapping up the observable state, it's opinionated, keep it simple, it removes a lot of boilerplate code. It has a snapshot and patch functionality. We don't have to do multicasting. We don't have to clean up subscriptions. We don't have to do this combination logic, but we still can if we want to. It's junior friendly, and you have one state machine per component. So I feel like there's an elephant in the room. Does anyone have an idea what name that elephant might have? No, it's not NGRX, but you could connect NGRX observables to your local component state as well. Anyone? It starts with an S and it ends on ignal. Yes. So reactive pattern number 6 is signals. So with signals, you have pieces of reactive state, and that's exactly what we have just done. With signals, you have initial values, and again, that is also what we have done. In signals, you avoid combine latest and with latest from. That's kind of what we did as well, especially with the snapshot. And with the signals, you also avoid async pipes, and that's why we're using these view models. So what I'm telling here is that using these reactive patterns can prepare us for signals, because signals are not ready yet. I'm not going to say more about signals because I don't want to steal the thunder of Pavel or Michael. But this way of programming might make it easier to take the leap towards signals. In this article, I have created a SIP principle. So the SIP principle stands for source observables, intermediate observables, and presentation observables. I refactored it to observable state, and in the last step, I refactored it completely to signals. So definitely check that out so you can see how hard it looks alike. One more slide about me. I founded this company in September. We do consultancy, Kickstart projects, we do some coaching, training, technical interviews, and we do it both on-site and remote. This is my Twitter handle. And I'm also giving Angular Proven Enterprise Solutions training the 11th of May. And I would like to give you a 10% discount with this code. You can come find me at the conference for some simplified swag. I have this awesome T-shirt, which is gonna be irrelevant in 6 months. It says, I am in the inner zone. I hoped for better, but okay. I also have stickers. So that's it. Thank you very much.